Hi guys, it's Mrs. Millison. Okay, you're in the last section of the first chapter, and this is where we start quantifying a lot of stuff. So let's look at the check your understanding on page 53. Here, coming down to my paper. So far in this chapter, we have learned how to describe a distribution. Okay, when we described a distribution, we used the little acronym SOX. S is for shape, U is for outliers, C is for center, and other S is for spread. Okay, so depending on the shape, we talk about the center and the spread. So we're going to talk about the shape and the center in this section, and then we'll do spread and outliers in the other sections. Okay, so come back up here. Come back down here. So the two shapes we're concerned with are symmetrical or skewed. Okay, and we'll talk about that more. And then you've learned in this section your two types of center are mean or median. Okay? All right, let's come back up here. So here, once again, is a stem plot of travel times to work for 20 randomly selected New Yorkers. Okay, earlier we found that the median was 22.5 minutes. So this is page 53, but on page 52, if you want to glance over here, hopefully work through an example of how to find the median, okay? And I'm going to talk about it. Okay, you can zoom in on this. So how you find the median, and we talked about that in the first couple sections. It's the center. It's the center item, okay? I've got a stem plot, so I can find the center from the stem plot. So there's 20 pieces, okay? So there is, before we do this, let's SOX this. Sorry, guys. Let's describe the shape. In order to do this shape, we have to kind of turn it on its side. Always go from lowest to highest. So, no, don't turn that. So we look at our distribution and we see a peak and then it kind of dips down. So if I kind of draw a curve, it's right skewed, okay? So this is unimodal, because there's only one peak, and right skewed, okay? So the center we're concerned with is the middle, Outliers, I don't know, possibly 85 minutes. I don't know, we'll quantify that later. And the spread, the only spread we know right now is range. So our data ranges from 5 to 85, so we have a range of 80 minutes. So that's 5 to 85, okay? So let's concentrate on center, okay? So again, we're going to do median, which is just the center observation, the observation in the middle. Oops, I spelled observation wrong. That's an A. Okay, there's 20 pieces of data here, so our sample size is 20. So where's the middle of 20? Well, if you go 10 in from the right and 10 in from the left, there is no middle item. So we have to go to the 10th and the 11th observation, okay? So if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, and I'm going to check it from the other end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So these are my center observations. So to calculate my median, I just take, so that's 20 and 25, add them up and divide by 2. So sticking that in the calculator, we get 22.5 minutes, and we had already calculated that in our example, okay, from the previous page. So then it says, come on up to the question. Based only on the stem plot, would you expect the mean travel time to be less than, about the same as, or larger than the median? Okay, well, I went ahead and turned the distribution on its side so we could kind of analyze it. Come up here.
Where?
Up here. Okay, so again, when I turn it on its side, we look at it and it's kind of right skewed. The median was at 22. Here was the median. So the median was around here. Okay, since it's skewed, let me extend my line up here. Since it's skewed, the mean always falls more towards the skew. So the mean's going to go a little bit past the peak. Okay, so if we want to refresh real quick, in a symmetrical distribution, the mean and the median should be the same at the peak. But as soon as you skew, okay, if you skew this way, The median falls off the peak a little bit, but the mean falls off the peak more and follows the tail. So even if I did a left skew, that's not very pretty, but whatever. The median would fall off the peak and the mean would fall more into the tail. So in this case, actually in this case, the mean is greater than the median. Here, the mean is less than the median. So for this case, we're expecting the mean to be greater than the median, okay? So let's go ahead and calculate the mean. So the formula for the mean, or the average, which is what you are used to hearing the mean as, it's just the sum, that's a Greek sigma for sum, of all the observations divided by the sample size, or the number of observations. So that would be 5 plus 10 plus 10 plus 15 plus 15 plus 15 plus 15 plus 20 plus 20 and so forth, plus 85, all divided by 20, okay? Of course, I'm not going to write all that. I'm just going to do it in the calculator. Can you see? Let me do it like that. Okay, I'm going to do it all in one full swoop. So I need to see my data. So 5 plus 10, how many 10s are there? And then there's 4 15s.
You just multiply it.
I know, but I want to see each observation. 3 20s, a 25, 2 30s, 2 40s, a 45, where am I? 2 60s, and a 65, and an 85, all divided by 20, because there were 20 observations in our data. Of course, it's going to give me a fraction, so I'm going to hit math, turn it into a decimal. So 31.25 is my average, or my mean, okay? So my mean is 31.25 minutes, which makes sense to my picture, okay? So my mean we thought was going to be greater, so my mean is 31.25 minutes, which is greater than my median, which was 22.5 minutes, okay? And that's exactly what we thought based on the shape of the distribution, okay? All right. And don't worry, when we do larger distributions, I'm going to show you shortcuts how to find the mean and the median in the calculator. But right now I want you to do it by hand because you understand it a little bit better. Okay, last question. So this was, I'm not even numbering these. This was number 2 and number 3. Can you come up here so I can read the question? Would the mean or the median be a more appropriate summary of the center of this distribution of drive times? Justify your answer. Well, again, coming back to our shape of our distribution, means react more, means react to extreme values a lot more than medians do. So since the distribution is skewed, so I'm going to say, since the distribution of drive times is skewed right, the median is a more appropriate summary of the center because the median is resistant to extreme values. The mean is not resistant. If you have an extreme value, like way down here, way up here, it'll pull the mean farther away from the center, okay? So since the distribution of drive times is skewed right, the median is a more appropriate summary of the center because medians are resistant to extreme values. Resistant to extreme values, okay? And that concept, come on down, you can't see. That concept is very important in statistics, okay? Just real quick, never mind, I'll talk about that later. Okay, so that's it for that. Check your understanding. The last two will tackle spread and outliers. Okay, thanks a lot.